So, let us solve one problem on product differentiation, and in this problem what I have done, I have combined both the sequential and the simultaneous decision, because in the case of product differentiation we have done separately one section where firm decides the location simultaneously, and in another section we have done firms decides the location sequentially. Okay. So, now here in this question these two things are combined. So, let us look at the problem. So, consider Hoteling's linear city model. Suppose there are 3 firms, firm 1, 2 and 3. The length of the city is unit interval. The consumers are uniformly distributed over the unit interval, and the number of consumers at each point of the unit interval is 1. Okay. So, it is specification is same till now. The price is fixed at 1 and each consumer consumes a single unit of the output. Utility function of a consumer located at the point theta in the unit interval is this if there is this V, that is the value the consumer gets from the consumption of that good, and this is the utility that it derives from by traveling some or making some traveling some distance to buy that product, and this is the price. Price is 1, so it is equal to 1. If consumer buys from the firm located at point theta I, whereas the consumer is located at the point theta. Okay. And theta I will take depending on the location from which firm it is buying, it will get the utility, and V is the value to the consumer from the consumption of 1 unit of the good, and this is the transportation cost of the consumer for buying from the firm located at point theta I unit interval, and P is the price of it, which is fixed and same for each firm. Okay. It is fixed at this, and the cost of production is 0 and there is no entry cost, because here the firms are also entering sequentially one after another. So, no entry cost, and once firms select a location, it cannot change its location. So, once it chooses a location, it is fixed, like firm 1 when it moves first, if it chooses the location, and then when firm 2 and 3 they enters, it cannot change its location, it will be there only. Now, consider a 2-stage game where firm 1 enters the linear city in stage 1 or locates in the linear city. First, firm 2 and 3 observes the location of firm 1 and then simultaneously choose their location in stage 2. So, firm 2 and 3 they are moving simultaneously. Find the subgame perfect Nash equilibrium of this game of choosing location in the unit interval. Okay. Now, let us solve this. So, this is the unit interval. Okay. Now, what happens? L1 is chosen in stage 1, L2 and L3 is in stage 2. Okay. So, we will solve this using backward induction, and we have to find the subgame perfect Nash equilibrium. Okay. So, what we are going to do? So, first suppose L1 is this, or let us solve this. Suppose this is, suppose L1 is at this point, 0.5, this is the middle, and L1 is here. Then in stage 2, firm 2 can choose this and firm 3 can choose this position. So, this is L2 and this is L3. So, L2 is equal to left of L1 and L3 is right of L1. So, L1 is sandwich. Sandwich between these two. Yeah. So, when it is sandwich, so it means what? profit, it is not getting any consumers. So, its profit is 0, right. So, it will not select this. So, from here we get that it will be either in this or it will be in this, okay? It does not matter. Now, suppose L1 is here. Now, in stage 2, what is happening? Farm 2 and 3 are entering simultaneously. Now, if suppose farm 2 selects this, okay, farm 2 selects this, and farm 3 while deciding its output, because it is deciding simultaneously along with A. So, it will select, if it will compare this half of this and it will compare this. So, it will farm 3 compares 1 minus L2 and L2 minus L1 half of this, because if farm 2 it locates suppose here, L2 is here, right of this, then the best response of farm 3 is to locate here, okay, because you can simply use the argument that you have got from when there are two forms and suppose unit interval, we have got this located the middle, because if it locates here, the other form also locate here and it gets the whole. So, that is why this is not I. So, you can argue in that way. So, in this line here it is, this is not optimal. So, if this is not optimal, then it will look at somewhere here. So, it has chosen suppose this L2 is this. If L2 is this, then farm 3 will compare this. Now, because L2 and L3 is being chosen simultaneously, so if this is L1 and suppose this is L3, because L3 is not going to be here again, same using the same argument, then farm 2 compares 1 minus L3 this distance and it compares this half of this, and it will also compare this, because suppose it will compare this and it will compare L1. If L1 is greater, then it will locate here, and if here also it will compare L1. So, out of this tree length it will choose the one which is the maximum. So, from this argument we get that so given in location L1, farm 2 and 3 they will always try to see if this is L1. See this is L1, this is L2, then farm 1, 2 will either locate here or it will locate here, because if it locates here, then best response of farm 2 is not to here, but to shift till this point, because it will get a more A. And so, L1 is this is 0.5, and if this is L3, then L2 will locate here along with this L3. So, this is, I hope it is clear, because if it is L2 is here, then farm 1 L3 will move this, or if L3 is here, farm 2 will gain by moving in this direction. So, that is why L2 is equal to L3. This is true. Now, when this is true, if we from this diagram, because this length is very small, so we get that this should be true. Now, this should be true when 1 minus L2, this is equal to L1, this distance is equal to this distance. So, from this we get a condition that L1 must be equal to 1 minus L2 and L2 minus L, and L2 is equal to L3. So, and when we solve this, what do we get? We get this. So, we get by 4, and this is equal to L3, and L1 is equal to 1 minus L2. So, L1 is equal to 1 by 4. So, L1 is equal to 1 by 4, L2 is equal to L3, it is equal to. So, this is another. So, this is the subimperfect Nash equilibrium. So, what do we get? We get this 1 by 4 is going to be L1, this 3 by 4 is going to be equal to L3. Because if you look at any other point, you will see that it is not a Nash equilibrium. Why? Because if it moves here slightly less than this, so then what is happening? L1 is reducing, so there should not move here, but if it moves slightly here in this, so if it is here, suppose L1, then what is happening? This length is greater than this length. So, this form will shift here, another form will shift here. So, it will be like this. So, if L1 is greater than 1 by 4 and it is less than 0.5, then again what is going to happen? This L2 will be either, so L2 may be left of L1. So, again form 1 may get sandwiched. So, that is why it should not move here. So, that is why this is one subimperfect Nash equilibrium. And we may have another subimperfect Nash equilibrium, which is L1 is equal to 3 by 4 and L2 is equal to L3 and it is equal to 1 by 4. Yes. So, we will have only these two. Now, here you will see what is happening. So, this model is about product differentiation and this is about horizontal product differentiation. So, here we will see that one form is differentiating and the other two forms are producing homogeneous product. They are not differentiating, but they are differentiating with respect to the product of form 1. Okay. Thank you.